Last section in chapter 8 is improper integrals. And these are integrals that have as their limits of integrability, I guess, the LOI, with a nice little infinity sign there. So instead of integrating to infinity, we put a limit here as b goes to infinity, and we put a b here. That's all. Same thing here with negative infinity. Then we'll do it to we'll put like some type of variable there, and we'll go to negative infinity. It doesn't matter to a, b. It can be any variables really, except x, of course, because then it screws up the whole thing. Now, if this converges, because they'll ask you, does this converge or does it diverge? Well, it converges if the limit exists, and you get an answer just like you've done it. Else, it diverges. You can get infinity, negative infinity as answers, and that would be a divergent integral. Okay? Something what I'm looking about lands, I'm talking to you. If we wanted to look, if we wanted to look at an integral whose area maybe is that, well, you see that that area is getting smaller and smaller and smaller, but it never really touches zero. So that's kind of where we're going here. And it could be any of those functions. It could be a graph like the normal curve, okay? But that's where we're going here. Or we're taking it from 0 or from 1 all the way there, okay? However, if I'm coming over here, what if you have both infinity and negative infinity here? Well, what happens is you choose a number that's in between, like 0. Okay? 0 is a great number to pick. You could have picked 100. You could have picked 1. It doesn't matter, but you pick an arbitrary number, and you have it from negative infinity to that number, and then from that number to positive infinity with the limit there. All right, we're going to do about 3 examples here to show you what's happening. All right, so here we go. Example number 1. They're not done already for me. Isn't that crazy? I'm actually doing this one live. All right, here's one of them. 0 to infinity of e to the negative x. Well, what I'm going to do is I'm going to say that's the limit as a goes to infinity of 0 to a e to the negative x dx. Well, you know the integral of that. I think I taught you the integral of that to be negative e to the negative x. But now I'm going to evaluate it at a and 0, and the limit as a goes to infinity. So I get the limit, this equals the limit as a goes to infinity of negative e to the negative a power plus 1. Well, plus 1, remember, it's minus. When I put 0 in, it's minus the negative 1, so it's plus 1. Now, let's talk about what that looks like. That is a fraction that looks like this. 1 over, or negative 1 over e to the a, plus 1. Now, when I send this guy to infinity, this whole thing is getting bottom heavy, which means it's 0. So the answer is 1, and it converges to 1. Not too bad, all right? Once again, take the integral, you have this limit thing, and you carry the limit all the way through. Let's do another example. Let's do the integral from 0 to infinity, okay, of 1 over x squared plus 1. Well, that's going to be dx. I'll put dx up here. So that's going to be, that you're going to love this one. So this is a DiVincenzo classic problem. Limit as a goes to infinity. You can pick any number. I pick a or any letter. I pick a or b, and 0 to a, and it's going to be dx over x squared plus 1. So Any takers on that integral? Any takers? I heard it. Peruzzi, I heard it. I think I heard it from you. This is equal to arctan. The limit as a goes to infinity of arctan of x evaluated at a and 0. So that's the limit as a goes to infinity of arctan a minus arctan 0. Well, the arctan of 0 is 0. However, do you remember the graph here? This guy is approaching, remember that graph looked like this. Okay? It is approaching pi over 2. So my answer is it converges to pi over 2. I needed to show you a little arctan because, I mean, we've missed it. All right? Let's do another one. Let's do another one. All right. Let's do a crazy one here, okay? We'll go 0 to 1, and we'll go dx over the square root of x. Well, there's no infinities in this one, and that's what you showed me. Although, that's a problem. The problem is 0. It's not defined at 0 at all. The square root of 0, I mean, we blow up there. It's no good. Let's make it the cube root, by the way, because that's what my answer has. That's what my paper has. All right. So what we're going to do is we're going to make this guy the limit as a goes to 0 of a to 1, and this is going to be x to the negative 1/3 power dx. I made it look nicer for you. Okay. So now, but we have to come through the right. That plus and minus doesn't matter very much, but we have to come through the right. Why go to 0 going this way out of it? We come through the integral. So it has to be to the right. I don't know if that's going to make a difference in the end. I mean, we'll see. Maybe we'll see a problem that makes a difference. Maybe it doesn't matter. But I know if you wrote it on the AP exam, you have to put that plus there. So now this becomes, if I'm right, after I integrate, it's the limit. So this is after integration, 0 to the right of 3x to the 2/3 power over 2, evaluated at 1 and a. Okay. Well, at 1, it's 3/2. So it's 3/2 minus the limit as a goes to 0 of 3a 2/3 over 2. Well, what happens here? This guy goes to 0. So I'm just left with 3/2 as an answer. So that's our answer. All right? But we had to take into consideration where it's defined, and it's not defined at 0. All right. Let's try. Let me show you one that diverges. So you know what the answer is going to be here, but let me show you one that diverges. Because every single one we've done is converged. Here we go. We have 0 to 2 of dx over x cubed. The problem, once again, is the 0. So this is going to be equal to the limit as a goes to 0 from the right through the integral. And by the way, if it was up here, if that was the problem, then we'd go to the left because we still want to go through the integral. And this would be of x to the negative 2 over negative 2 evaluated at 2 and a. So at 2, we get negative 1/8, I believe, because this is the same thing as the limit, get out of there, of a going to 0 from the right of 1 over x squared negative 2x squared. So that when I plug in 2, I'm going to get negative 1/8. Then when I subtract the limit as a goes to 0 of 1 over negative 2x squared, I got a big problem. This guy is just going to be infinity. This guy's going to 0, so this guy's getting very small. This guy's going to infinity, actually. So this one diverges. So here is a diverging, I might have said series, but I'm getting ahead of myself. But that's one that diverges, okay? We can combine both of them and have a doubly improper integral. Okay, and I'm just going to kind of show you this. Let me see what I can do here. So this is the last one I'm doing. Last example. And I didn't say 2 more, so this is definitely the last example. It's from 0 to infinity, and it's dx times or over the square root of x plus 1. So we got problems. I got a problem at 0 because it's not defined at 0, and I got a problem at infinity because it's not defined at infinity. So I'm going to break this up and say it's the limit as b goes to 0 from the right, and that's going to be of 0 through, and I'm going to pick a number. I'm going to pick a number like 1. Why not? 1 of dx over square root of x plus 1. That can be arbitrary. Plus, now the limit as a goes to infinity, okay, of 1 to a. And it's the same thing. They're the same as that. So you have to break it up, okay? I could finish this. Let me finish it. So this really becomes, if I'm right, the limit as b goes to 0 from the right. And now this is going to be 1 over, I'll distribute, so I'll get x to the 3/2 plus x to the half power. You like me choosing these nice numbers. And then plus the limit as a goes to infinity of, same thing, 1 over x 3/2. Oh, I didn't put my limits here. This is b, and this is 1, and this is a, and that's this is a, and this is 1. My bad. It's kind of the whole point. All right. X to the 1/2 power dx. Now, when I go ahead and do this problem, if I'm right, I look, and if I say that u is x to the 1/2 power, check this out. U squared then would be x to the 3/2 power. Agreed? So I actually have these two, believe it or not, and this is like a level 5 problem here, the hardest you can get, all right, is going to be arctan. So it's going to be 2 arctan, all right, 2 arctan square roots of x, because there's the u. Du is 1/2 x, so that's what the 1/2 x to the negative 1/2. So that's what it becomes, and this is at 1 and b. Well, we learned at 1, arctan of 1, I believe arctan of 1 is, I believe, pi over 4. Pi over 4 times 2 is pi over 2. And then it's minus, when I put in b, 0. The arctan of 0 is also pi over 2, but it's divided, it's times 2, so it's pi. So I get negative pi over 2 for this one. For this one over here, let me do this one in red. It's going to be the same thing. 2, nope, 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 nope. This is going to be limit plus limit as a goes to infinity. My bad. Whoa, my bad. The arctan of 0 is 0, so you just get pi over 2. My bad. 0 pi over 2. 0 is just 0. I was thinking this one over here. Sorry, friends.